Okay, what we have here tonight is a B&K 1477. It's a 15 megahertz scope. The manual that comes with it was copyrighted in '85, so assuming that the unit was built in that year, then it'd be about 27 years old. The unit when I got it was in pretty sorry shape, had been abused quite a bit. The cabinet had a lot of marking on it with permanent marker. I wound up having to respray the cabinet. It did a fairly decent job. There are a couple little drip lines on it. But all in all, it looks quite good, especially compared to what it was. The unit didn't come with a handle, so that's a negative. And outside of that, though, I was able to completely clean up 27 years worth of tarnish off of the switches and out of the pots, and we've got it. Went through a calibration on it. We have it working very well now. Both, well, in fact, all functions. We have both channels A and B, and magnification working. All of the ranges work, and we're going to take it through some calibration checks to just prove that to you. The front plate looks quite decent. Not perfect. I mean, it shows a little sign of wear, a little rub right up in here that's noticeable. A small scratch on the area here, but in general, you can see it's quite nice. I did replace the lens, put a newer lens in it. And it will come with a set of brand new probes, 20 megahertz probes. So you get a set of those. We'll go ahead and give it a go. Let's take a look at just a few things here. For instance, let's position the trace and demonstrate the intensity. Full on, full off. Usable. Then the focus, blurred, blur, and then centered. It has an astigmatism control for a little finer line to it, but this line is really quite bright, quite intense, and quite fine. The video doesn't do it justice. I know that from working with these things before. But it is a very fine line, very fine trace. Looks very good. We have a illumination control for the grid. It's working. We have we can display an A mode. We can display B mode. We can display both traces. As you can see. We can do A plus B or A minus B as well. Really find very little use for those myself, but obviously somebody does. We have a continuously variable control. I've got this thing calibrated so the control's operation doesn't change the calibration setting. That's all part of the calibration. Same thing with channel B. But I assure you that the operation of it does work. And we can change our trigger source from channel A to B, or external. We can change our slope from positive to negative. We can change video input from positive to negative. We have triggering for the scope. Can either be in normal mode, where you have to have a signal in order to get a trigger. That's the way that works. Or we can go into automatic, where it'll run. You'll see something all the time. I normally run an auto like that. And then we have the horizontal centering. It's working just fine. The magnification, which we demonstrate during the calibrations, you'd have to have a signal on here for you to see it. So that's some of the basic things. Let's take a look at the calibration input. We'll go switch to channel 2 to show that. Alright, I just took myself up to the calibration point up here. And we'll go ahead and put ourselves on AC and our trigger source to channel B. And there you go. Not a problem. I could do the same with channel A. We'll try that right now. I get it to let go. Give me a moment. Alright. And we'll go ahead and bring ourselves down again. There we go. Not a problem. Okay. Channel A and channel B are both working fine with the calibration point. Minor thing. Let's get on with the calibration checks, and we'll come back and finish up later. Okay, we're going to go ahead and check the vertical linearity of the scope on channels A and B. Right now we're on A. We're going to be applying DC voltages and observing the trace as it moves up the screen to see if it represents the appropriate voltage with a number of divisions on that range. So I'm going to turn off the light to get a little better view of the screen. Hopefully a little less glare. Let's try that. Okay. Right now we're on the 0.01 volt per division, and we're going to go and try and step up one division at a time. One step at a time. One. This would be 0.01, 0.02, 0.03, 0.04, 5, 6, 7, 0.08 volts. Perfect every step. Thank goodness. Alright, we go to 0.02 volts per division. It's going to take 2 steps for the same. So here's 0.01, 2, 0.03, 4, 0.05, 6, 7, 0.08, 9, 1 volt. Alright, we're going to start at 1, 0.11, 0.12, 0.13, 0.14, 0.15, 0.16. Perfect. Alright. 0.05 volts per division. Alright, we're going to go 2 divisions at a time this time. There's 1 volt, or that would be 0.1 volts, 0.2 volts, 0.3 volts, 0.4 volts. Okay. We're going to go to 0.1 volt per division. Alright. And there's 1. That's 0.1, 0.2, 3, 4, 5, 6, 7, 8. 0.8 volts. Perfect. There's 0.2 volts per division. We're going to go 2 steps at well, I'm sorry, we'll go a half step at a time. Here is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we can pick up one more here. There's 11. That's as high as I can go with this particular calibrator. We'll go to direct now. We've been on the divide by 10 on the probe, so now we're going to be going direct, and we'll pick her up from here. Let's see. Okay. We're still on the 0.2 volt scale, so that's 1 volt right now. That's 5 divisions times 0.2 is 1 volt. 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. Okay. Now we go to 0.5. We'll go 2, 2 steps at a time. 1, 2 volts, 3 volts, 4 volts. Perfect. We're on the 1 volt per division. All right. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And then we go to 2 volts per division. We'll get only part way through the scale, but we'll do it. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 volts, and that makes 11 right there. That's as far as we can go with the calibrator. Alright, we're going to move to channel 2, or B, and we're going to go through the same steps with the calibrator here. And channel B, source on B, and make sure we're 0. That looks pretty good. We want to be divide by 10, and we are in the lowest range, 0.01, so we're going to go up 1 step at a time. 1, it's 0.01, 0.02, 3, 4, 5, 6, 7, 0.08. Perfect. Alright, now we're on 0.02 volts per division. It's going to take 2 steps. 1, 0.02, 0.03, 4, 5, 6, 7, 9, 10. We'll start at 10. 0.11, 0.12, 13, 14, 15, and 16. Perfect. Okay. 0.05 volts per division. We're going to go 2 steps at a time. There's 0.1, 0.2, 0.3, 0.4 volts. Perfect. There's 0.1 volts per division. We're going to go up 1 step at a time. There's 1, 2, 3, 4, 5, 6, 7, 8. So that would be 0.8 volts. Okay. 0.2 volts per division. Check my 0. Okay, 0.2 volts per division. We're going to go 1/2 a step at a time. So here's 0.1, 0.2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to go now, we'll take this back down. We're going to go from times 10 on the probe setting to direct. And this will give us a little more voltage to play with because it doesn't divide it down. We are on 0.2 volts per division, so here's I'm going to start out at 5. 0.2, 4, 6, 8. There's 1. I'm sorry, that's 1 volt. Okay, 1.1, 1.2, 3, 4, 5, and 1.6. Okay. Now we go to 0.5 volts per division. Okay, check 0. Looks good. Oops. Did look good. Looks good there. Okay. We're going to go up we're going to go up a volt at a time, so we're going up 2 divisions. Here's 1, 2, 3, 4. Perfect. Okay. We are now on 1 volt per division. Here's 1, 2, 3, 4, 5, 6, 7, 8 volts. Perfect. And then finally 2 volts per division. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so both channels A and B are reading very well from 0.01 volts per division to 2 volts per division, and they're giving you exactly what you'd expect. We'll take a spot check of 10 and 100 volts in a moment, and then we'll move on. Okay, we're going to spot check the 2 volt per division right at the moment. We've got 10 volts coming in, and we have 10 volts showing. Okay, if we go to 5 volts per division, that's 2 divisions, that's 10 volts. There's 0, 10 volts. And then 10 volts per division, that would be 1 division. That's 10 volts per division, so we got 1 division. I can't go to 100 yet. We'll go to 20 volts per division, and then we'll go to 100. Let's make sure we're zeroed. 0 looks good, and we go to 100, and we see ourselves up at 5 times 20 would be 100 volts. All right, let's take a look at channel 2, or channel B. And put ourselves back on 10 volts. We're on 2 volts per division. We're on B, source is B. 0 is good. And let's go. All right, that would be 10 volts. On the 2 volts per division scale, 5 divisions, 10 volts, yes. We go to the 5 volt scale, that would be 2 divisions, 0, 2. 10 volt scale would be 1 division, and 20 volt scale would be a half division, but then we can go 100 volts, and we're back up to 5 times 20 would be 100 volts. So we've just checked both channels for input of 10 and 100 volts on the remainder of the ranges. And everything checked out wonderfully, so you're going to get a good scope here, whoever bids and wins. You'll be able to measure DC voltages very accurately on all ranges. Let's go ahead and check the frequency now, the time base, and if the time base is linear, then we'll go ahead and do some triangle waves and do a frequency check. So bear with me, and we'll continue. Thank you.